All right, guys, thanks for returning. For this one, we are going to find the confidence interval for a population proportion. And in it, we are going to go through this example. It says, you are interested in the opinions of adults as to what age group they believe engage in the most risky behavior. In the study, adults are given the option of 13 to 19-year-olds, 20 to 30-year-olds, or 31 and above. Of the 250 people interviewed, 186 of them selected 13 to 19-year-olds. Construct a 95% confidence interval for the population proportion of people who believe teenagers are the most likely to engage in risky behavior. Well, this actually gives us all the information we need to solve it. So let's start by just identifying what we need. I've written down what we need over here. We're going to need our x, our n. We're going to use those to find our p hat. We'll use our p hat to find our q hat. We'll use our critical value of z, which is actually a constant. We'll go over that in a minute. Our standard error of p hat, which is going to be this equation right here, p hat times q hat over n, which will have all of those informations right here. And finally, E is our margin of error, which is our critical value times our standard error. From there, we'll just add and subtract that critical value from our p hat, which we will find in just a little bit. All right, so let's start by finding out our number of successes. So our number of successes are 186 because 186 people said teenagers engage in the most risky behavior. So 186 of 250, this is our n, and this is our x. Let's add them. So x was, I believe, 186, n was 250, which means we could find our p hat by taking the top number and dividing it by the second number. Let's see that now. So 186 is going to be divided by All right, so 186 is going to be divided by 250. I don't know what that is off the top of my head, so let's go ahead and plug it in. 186 divided by 250 gives us 0.744. Let's call that 0.74. All right, we know that if our p hat is 0.74, then our q hat is just going to be 1 minus that. 1 minus 0.74, I believe, is equal to 0.26, but we can check it. 1 minus 0.74, yep, 0.26. All right, our z, or critical value of z, is actually going to be a constant, and it's based on our confidence. Well, our confidence was 95%. So we know that 95% confidence gives us 1.96 as a critical value of z. Well, let's find our standard error. Standard error is going to be the square root of p hat times q hat over n. So let's plug that in. Square root of p, give it a little hat, times, let's give our q a little hat as well, q hat, all divided by n. Okay, so that's going to give us the square root. Oh wait, let's actually fill these in. Our p hat we said was 0.74. Our q hat was 0.26. And our n was 250. All right, let's find out what that is. So 0.74 times 0.26 divided by 250 is this. Let's square root it, and we get approximately 0.027. Let's call that approximately 0.03. We can actually change this to approximately 0.03. 3. All right, let's take our standard error and multiply it with our critical value. That's 1.96 times 0.03 equals 0.0588. Let's call it approximately 0.06. All right, we now have our 0.06. Let's go ahead and add and subtract that to our p-hat. So our p-hat was 0.74, and we are going to subtract from that 0.06. So 0.74 minus 0.06 gives us 0.68. Okay, and we'll do the opposite now. 0.74 plus 0.06 is going to give us 0.80. And we now have our low value and our high value of our confidence interval. Let's write it out mathematically. So our low value, 0.68, is less than our p, which is less than our 0.8. In other words, our probability or population proportion is going to be between 0.68 and 0.8. Let's write it out as a sentence. We can be 95% confident that the, what are we calling this? That the population proportion of adults believe that adults who believe that teenagers, what were the exact words we used? Engage, there you go. Engage in the most risky behavior is between 68% and 80%. That's going to be our answer. Thank you so much for your time.